Okay, we're going to talk about geometric proof now that we've finished going over the algebraic proof stuff. So a geometric proof is a proof which uses geometric properties and definitions generally to prove something about a geometric figure. And as before with the algebraic proofs, it begins with a given statement, ends with a proved statement. And so you list the steps of the proof on the left column and whatever your justifications or reasons are in the right column. And you can use definitions, postulates, previously proven theorems, algebraic properties, anything like that as part of your reasons. Now, a two-column proof isn't the only type of proof there is. There's also what are called paragraph proofs, which you essentially run through the steps of the proof in a paragraph form, and you don't necessarily always have to give the reasons why something is true, but it's kind of understood that if someone were to ask you, well, you could do that. And another type is called a flowchart proof, where you're kind of listing the proof as a flowchart, as a list of steps that you go from one to the other as you go through the process of proving whatever you're trying to prove. Now, when we talked about the algebraic proofs, we talked about our different properties of equality. Well, when we move over to the geometric proofs, there's some other properties that come with them, coming out of the fact that line segments that have equal lengths are congruent, and angles that have the same measure are congruent, and so we end up with some properties of congruence that come out of this idea. So first off, we have what's called the reflexive property of congruence, which says that some figure A out there is congruent to figure A. And the reflexive property of congruence is actually much more useful than the reflexive property of equality is, because that one is like, well, okay, so these two things are equal, this is equal to itself. What does that matter? Well, especially when we start getting into triangles, this property comes in very handy. Then we have our symmetric property of congruence, which says that if some shape is congruent to some other shape, then you can flip it around and it'll still be true. And then finally we have our transitive property of congruence, which says that if figure A is congruent to figure B, and figure B is congruent to figure C, then figure A is congruent to figure C. So here's an example of a two-column geometric proof. If you don't focus on anything else, focus on the idea that your given statement here, that's always going to be kind of at least one of these is always going to be the starting place of your proof. And whatever it is you're trying to prove should always actually be the last statement of your proof. And then it's just a matter of how do you get from here to here. So let's see what we've got here. We have, basically we're given that angle BAC is a right angle. Here's our little mark. And we're given that angle 2 is congruent to angle 3. And what we want to prove is that angle 1 and angle 3 are complementary. Okay? So we start off with, okay, we're given that angle BAC is a right angle. So that's going to be given. You don't always have to list everything at once. Sometimes it's better for the flow of the proof to list the pieces that you're given as you need them. So we're going to start off with just listing this piece right here. Okay? Then if BAC is a right angle, what does that mean? Well, it means the measure of this angle is equal to 90 degrees. And the reason for that is the definition of a right angle. So any of these words that we've defined, any of these properties that we've talked about are basically available for you to use in this proof. Now, number 3, the reason for that is angle addition postulate. Okay, well, what was angle addition postulate? It says, well, the part plus the part is equal to the whole. So that tells me then that angle 1 plus angle 2 is equal to angle BAC. It's just that when we're writing this out, we have to use measure because that's the only way we can add angles together. And so we have the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle BAC. Well, we just said up here that, well, the measure of angle BAC is 90 degrees, so we can plug that in here, and that's my substitution property. And so now I use my angle 2 is congruent to angle 3 as my given statement. Now this next one we're going to use quite a bit, which is this definition of congruent angles. If two angles are congruent, then their measures are congruent. So I have measure of angle 2 is equal to the measure of angle 3. Now that I have these two things equal to each other, I can basically replace this measure of angle 2 with the measure of angle 3, and that's my substitution property of equality. And then finally, I want whatever it is I'm trying to prove goes down here as definition of complementary angles because the two angles add up to 90 degrees. Okay. Now I know that was kind of a bit of a long, I mean, we're going to when we get to class we're going to start off with just little small proofs, but I wanted to give you a kind of an idea of what a longer proof looked like. Okay. So here's another example. We're given that angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary, so I want to prove that angle 1 is congruent to angle 3. Well, this is actually pretty similar to, if you remember one of the problems from the test, where if you've got these two things add up to 180, and these two things add up to 180, then these two things have to be the same. That's the basic idea of what we're doing. And so, how we go about proving it? Well, we're going to start off with, we're going to use both of our statements at once here. We're going to say angle 1 and angle 2 are supplementary, angle 2 and angle 3 are supplementary, and that's my given statement. And then I want to go in, okay, what does that mean to be supplementary? So there's my definition. So both of these have to add up to 180. Now, I've got the same thing here. I've got measure 1 plus angle 2, measure angle 2 equal 180 this way. So therefore, they're both equal. How long it is? Oh yes. First I want to turn these things around. So I've got 180 is equal to measure of angle 2 plus measure of angle 3. So I can flip it around. And so now I've got the measure of angle 1 plus the measure of angle 2 equals 180. And 180 is equal to the measure of angle 2 plus measure of angle 3. Well, that tells me I can set them equal to each other by my transitive property. So again, I'm setting up a little chain of things. And then finally, well, not finally, sorry. Then I can get rid of this angle 2 here because I can just subtract it from both sides, and that's my subtraction property. So now I have the measure of angle 1 is equal to the measure of angle 3, which means that angle 1 is congruent to angle 3 by the definition of congruent angles. Okay. You want to be careful when you're doing these that if I'm asking for, for these two angles to be congruent, that you go all the way out to this. You don't just leave it here at measure of angle 1 equals measure of angle 3. I mean, I know that if they're equal, they're congruent, but you have to make sure that you follow out to the last step by making sure your last step is whatever it is you're trying to prove. And don't skip this step right here. Okay, another one. Given angle 2 is congruent to angle 3, so these two are congruent, I want to prove that angle 1 and angle 3 are supplementary. Well, this is kind of the same idea as what we just did, because these two are supplementary because this is a linear pair, and so if these two are congruent, that means that these two have to be supplementary. Okay, so that's the idea of what we're looking at here. So I start off with my given statement. Then I'm going to use my definition of a linear pair to say they're supplementary. And because they're supplementary, then I use my definition of supplementary angles to go with this step. Now, I can now go in here and use my given statement, which says that measure of angle 2 is equal to the measure of angle 3 by the definition of congruent angles. Substitute measure of angle 3 for measure of angle 2, And now, okay, that's my basic definition of supplementary angles. So I'm done. All right. See you later.